So now we are going to have the next topic, which is going to be taught in Spanish. Antonio, are you around? Can you take over?
Yes, Jan, I'm here.
Okay.
Hola a todos, ¿qué tal? Soy Antonio Granjo,
Hello, everybody. I'm Antonio Granjo. I'm a box coach at Santander. And now we have a very special guest. We have Álex Soto Bueno, Director of Developer Experience at Red Hat. Hello, Alex. Are you there? How are you? Good morning. Fine. Ready. Very good. We're really very grateful and very pleased to have you here. It's a great pleasure to have you here with us. So that you all know, Alex is very excited about Java and automation in software, and he's a real believer in the open source model. He's the creator of the non-SQL unit project, a member of the JSR 374 specification of Java API for JSON processing, and co-author of a couple of books, Testing Java Microservices and Focus Book for O'Reilly, right? I think that's right. He's Java champion since 2017, international speaker, a professor at the University of La Salle Ramon Llull. He likes to talk about testing, about to implement continuous deployment in the 21st century. And the subject of his presentation could be Serverless Hybrid Cloud, winning the hybrid cloud. And before beginning, I would like to ask you to use the chat for any questions, and we will answer at the end of the keynote. So, Alex, are you ready to start? Yes, I'm ready. Thanks for the introduction. You didn't say anything that wasn't true. Great. I'll leave you with your presentation and I'll be back later. Okay? Okay, thank you. I think you can see my screen. And we're going to start the presentation. Yes, this is the title of the presentation. I'm Álex Soto, as Antonio said, and I think that the sessions are being recorded, so you can watch them at some other time, or you can see them again. And if you have any questions, you can follow me on Twitter at Álex Soto B. I'll be delighted to answer any questions. And if you want to be updated on Java issues, I sometimes write tweets about it. This is a keynote speech with interactive slides, and the links are on the slides. If you want to look at the slides later, these slides are bit.ly hybrid cloud Java, as you can see at the bottom of the screen. And you'll be able to access the public links for the demos. I've put it on the slides because they're a bit long, and you can access them if you like. But let's begin. And the first question that comes to mind is, what is hybrid cloud? And in the end, the definition is very simple. And we can see what it's about. A hybrid cloud is having a cloud environment where all the elements we have are a mix of public clouds, private clouds, and also on-premises infrastructure. We have a mix of all these elements. So our cloud isn't a single element, but is formed by various clouds. And this could be an example. We could think that a hybrid cloud is a matter of using several clouds, and that's normally the case. But we can also think that we have a cloud GCP, for example, and we have multiple regions. this is also a hybrid cloud. And the example I would like to show you here is that we have like 4 clouds, a cloud in Azure, a cloud in Google, a cloud in Amazon, and I even have a private cloud. In this case, the logo is Minikube. So I could also have this kind of structure. Have several cloud suppliers where we want to deploy our applications. And before go into more detail, I would like to start with an interactive demo so we can see what all this is about and see a practical case. This is the first link, the GitHub repository, where you can find all the instructions to reproduce this demo. And remember that all my demos work on QML. I'm going to use OpenChip, but if you want to do the demos on a Kubernetes, they also work with no problem. And we've tested it out on some packs. And the second link is the application. It's a bit of a long link. The application is as simple as this. It's very silly. I just send a message and I tell it when I want the message answered in uppercase or reverse. And what's the difference? You'll see this is a very simple application. The difference is that this application is deployed here. I don't know whether you can see it. This is GCP, this is Google. Just a second, let's see if I can move this. This is GCP. I have my OpenChip cluster deployed on OpenTime on Google, and I have my front end and I have my back end. The back end is going to process all the information, and the front end shows it to me. This is the back end and the front end. And here I have the same cluster, but now it's in Amazon, and I've deployed the backend, the same backend as in the previous application. I have 2 clouds, GCP and Amazon, both running with OpenChip. We'll see why in a few minutes. And in the case of GCP, I have the front end, this application, and the back end, which is in charge of processing the data. And in the case of Amazon, I have just the back end. I'm going to write Álex here, and Álex in uppercase. And here, hello, Álex. It says that this was processed by the backend that is deployed on Google on GCP. Hello, aloha, hola, reverse, Santander. And it sends us the reverse of Santander, all processed by GCP. If you ask why Google and not Amazon, the reason is that in the end, my request that goes to the hybrid cloud backend comes from Google. Since it comes from Google, the closest backend is the one in Google, and therefore it processes. We're always going to process the request as locally as possible on the hybrid cloud. But now let's simulate a failure in the backend. For example, the node in this cluster fails. The cluster as such could fail, or that there's some anomaly in this service. Let's simulate it. And this is the backend from Google. There's no longer a backend. In GCP, I just have the front end, but no backend. And what happens if I do the same now? I'm going to change it to Soto. And now automatically the request is processed by Amazon. In other words, automatically, I've been able to make a switch from Google to Amazon, and I haven't done anything. All I did was stop the GCP backend. I stopped it, and automatically it's all gone to the Amazon backend. So we can see that the hybrid cloud looks interesting from the point of view that you can have a single backend. And some of you might say, okay, that's fine, but I want to know how you did it. So first of all, what are the basic principles of the open hybrid cloud? First of all, we have to think about the consistency of the user experience. If we have several clouds, it's important as developers, as operators, as DevOps people, it's important to have an equal or similar experience. In other words, not to have to learn how each of the clouds work. And here, Kubernetes and OpenShift play a very important role, because how do you apply an application by doing you have an apply? I know that we could use CD Argo, but in order to simplify, we do a qcarol apply. So how would I deploy my application? On the Amazon cloud, qcarol apply. And how would I do it on Google, qcarol apply? And how would I do it on my private cloud, qcarol apply? The experience is consistent. It's always identical. Another principle is that we have deployment flexibility across several clouds or the same cloud, the hybrid cloud. It's a solution that's open, but we can choose what technology to deploy all the clouds with. If we want to use HEM, if we want to use customize, we use customize. We have the way of being able to choose how we deploy. One of the important things about hybrid cloud is that it enables us to access the latest technology, or the technology that best adapts to our business. And I'll explain. Let's imagine that I have a cloud on Google, on GCP, and it's deployed. And it turns out that because of my business model or whatever, I need a function that is in the Amazon cloud. Well, the open hybrid cloud enables us to carry out this kind of implementation or architecture. In other words, having the processes we're interested in Google Cloud, the ones that we're not interested in having there, because it turns out that there's a specific technology from another cloud. It could be Google, Amazon, Azure, etc. And we can have Amazon Lambda, for example. We can use Amazon Lambda while we could have all. Let's think about machine learning. Let's imagine that it's that the Google machine learning is better for our business. We could have that on the Google side and Lambda on the Amazon side. And finally, we're reducing the risk of errors. We're making our applications more resilient to problems, and we can have more trust in that they're always going to work. And we saw it in the previous demo where I was stopping a cloud and all my application continued to run with no problems. And this is thanks to the fact that I had a duplicate cloud. And why does OpenShift help us? Because it gives us a consistent experience on all clouds. What is the advantage of having a hybrid cloud? Well, first of all, we can have a disaster recovery. And we saw it on the demo. I stopped a backend and the system recovered automatically going to a backend on another cloud. And when it recovers, the whole traffic goes back to the original cloud. We also have the issue of low latency. As I said, in the hybrid cloud, the requests are always going to go to the closest cloud it comes from. If, for example, I'm in the United States, the request will always go to the cloud that's closer to the United States. If I'm in Spain, it'll go to the cloud that's closest to Spain. So with hybrid cloud, we can have data centers all over the world, and we'll always have the lowest possible latency. And finally, one of the problems solved by hybrid cloud is that there are countries that don't allow their citizens' data to go beyond the borders of the country, and that's fine until our application is working on Amazon. And in the country where they have this law, there isn't an Amazon data center. So what happens? We have to go to a hybrid model. We have to see what cloud there is in that country. Maybe it's a country where there's neither Amazon or Azure or Google, and we have to use a private cloud. Or perhaps there is Azure, but we use Amazon. So we have to deploy in Azure. And all these kinds of problems can be solved with the hybrid cloud. How does the hybrid cloud work? How can I implement that demo we've seen where I put out a request and it went to one cloud or another? Well, thanks to a technology that's called Scupper. And here we can see the same problem we saw before. And what Scupper does is to be installed as a proxy pod and a Kubernetes service in each one of the services that we have deployed in a hybrid architecture. Here I have my pod, the same application deployed in each one of the clouds. And what Scupper does is to create a tunnel between all these services. All the information that is exchanged between all these services is encrypted with MTLS and authenticated. In other words, we don't have to worry about this information being stolen because it's already made secure through Scupper.
Que veamos todos estos servicios como un simple servicio, ¿vale? Nosotros,
all of these services as a single services, and well, for developers or for users of the service, there's only one instance here when I said that we had the prompt end, the demo, and we had the backend too. But for the front end, there's only one backend. There's not a backend in each one of these elements. There's only one. And there's an element on top, which is the scupper, that decides where it's supposed to send traffic to Azure, to Google Cloud, or to Amazon. And anyway, well, let's go back again to the same demo. And what I'm going to do is show you what's going on at a more technical point of view, if you want to look at it that way. Well, if you have any questions, well, please go to the chat for your questions. I think that there aren't any questions, but anyway, I'll just look it up in case. It seems that there's nothing in the chat, right? Well, okay. Well, now what I'm going to do is show you the following. Well, look, here I have, this is what my cloud looks like in Amazon. And you can see that I've these machines up and running. And over here, well, this is where I have my cloud, my Google Cloud, okay? But first of all, what I want you to see that these are different. In Google, they are like this. And in Amazon, they are completely different. So if I want to use a hybrid cloud, Well, the first thing I have to make sure is that if I do this, I'm breaking one of the first rules, and that is that I was supposed to have a user experience that is consistent, but it's not consistent. I have to learn to see how Amazon works and also how Google Cloud works. And the same thing would apply if I were to use the Jiki implementation of Google or AKS of Amazon. So I can use the Kubernetes of each of these clouds. But what I should do, I should learn and see how each one of them works. But you can see that the difference right now, well, here, this is my cloud, my Google Cloud, and it's identical to my Amazon cloud. And this is thanks to OpenShift, because what it does is standardize. OpenShift standardizes the experience. It delivers a consistent experience through the clouds, because I can have my app and deployed through Amazon or through somebody else, and I'm going to manage it in the same manner, and I'm going to see it in the same manner too. And this is a very important thing when we are in the world of hybrid clouds, because it means that you don't have to learn all of the clouds that you're going to need along the way. And as I mentioned previously, I've said that Scupper is a pod that is created inside our app. And as you can see, here we have the hybrid cloud backend. And let's say that this is the business logic. And here we have hybrid cloud backend proxy. And as you can see by the labels, it's a scupper, and which is the proxy that I mentioned before. This is the proxy, is the logic that manages all of the information. And we can go back to the demo, and all I have to do is write Álex, and here, as you can see, I've already one iPod up and running in the cloud, and we can work again with GCP. So if I descale to 0, you can see that everything goes back again to Amazon. And this is the part that has to do with Amazon. We have the user, and here you can see how there's a hybrid cloud backend and a hybrid cloud backend proxy. And I suppose that you are saying that this is absolutely wonderful. Okay, well, let's write Álex, and I'm stopped him at the backend. And this is Scupper. Scupper manages this, and it's not my app. My app doesn't have a clue of how many clouds there are, because I could add on more clouds and the system would adapt. But that's because there's Scupper. But of course, some of you are possibly thinking, well, this is brilliant, and I like it. It's very powerful too. But what about cost? What about having two clouds running the same backend? Well, obviously I'm using double the amount of resources. So there's not going to be a double cost, because many of these apps are going to go to the same cloud, but in any case, I still have services and processes that are being executed, that are being run. So therefore, my cloud provider is going to charge me for them. And this is where we have the second part of the presentation, where we're talking about serverless. How can serverless help us? There are many definitions of what serverless is. We believe that serverless, it's not that there are no servers, because at the end of the day, the servers are somewhere. So they might be over the rainbow somewhere, as I say, but they are there. Serverless, well, from our point of view, is a way of deploying applications where we do not require any kind of server management. In other words, we are not going to deploy an app and say, look, I want to take this app And what I want to do is carry out a deployment of that machine or that other machine or some other machine. No, we're not going to do it that way. But rather what we are going to do is, look, well, I want to deploy my app. An app is going to be deployed wherever our infrastructure of the cloud believes that it's going to be a much better location. This is the first thing that we have with serverless. And then the second thing that is very powerful is that it's then executed and scaled, and we're going to be charged according to the exact demand that takes place at that particular moment. What does this mean? Well, what it means is that if we don't have a demand, in other words, if there's no request, the service is going to be scaled down to zero, which means that the service is not going to exist. And if it doesn't exist, that means that our cloud provider will not be able to charge us. And well, you could not charge somebody for something that doesn't exist. But what's going to happen once I file some requests? Well, what's going to happen is that the system is going to start to scale itself from 0 to 1. And if more and more and more traffic is generated, what's going to happen is that the system is going to scale even further more. And this is what serverless computing is all about, at least from our point of view. And what is Key Native? Key Native is a project of Kubernetes that allows us to use or to deploy serverless workloads. And the good thing about this is that it doesn't re-implement anything, but rather it just uses the Kubernetes that we already know, or I don't know, a deployment or a service or a pod or whatever. And these are this is what Knative uses to implement serverless. But what I think makes it even much better technology, which can help us a lot too, when we start to work with a hybrid cloud. Well, Canopy works with apps that are containerized or container-based applications. So that means that we always have to use a container for Key Native. And the major advantage that we have when we use containers is that we can change from one cloud to another without having to carry out any migration. Let's think about the following example. What happens if I have some Amazon landers? Well, a part of the serverless that is like that, we have our landers installed, and it so happens that one day we have to go to another country where they don't have Amazon, but they have Azure. And in this case, what we would have to do is we'd have to take the landers and take a look at them, take a look at their core functions, which is a development cost, and there could be mistakes. However, if we use Canary, as these are containers, Key Native, we can go from one cloud to another without having to concern or be worried about migration, and that is a very important thing. What's important in relation to Key Native? Well, that you can scale to zero the pods. So that means that if there is no pod, it means that we are not using memory, and if you're not using memory, you can't be charged for that. And then we have another important thing that this has is that you can go from 0 to n. And if I'm at 0 and I receive a request, it goes to 1. But if it receives 1,000 requests, perhaps I have to go up to 2 pods because I'm asking for very, very high workloads. So what I have to do is scale it up a little bit. And then we have revision systems where we can do blue, green. And there's also a system to be integrated into architectures based on events. If you're using Kafka, I think he said, what you can do is integrate Kafka in the event system. So as I said, this is one of the traditional elements of Kubernetes, where we have a deployment, but with Key Native, we increase the level, and what we have are new objects like Key Native service at configuration and revision, and all of these elements communicate with the traditional elements. So if you want to learn more about Key Native, well, here's the link, and you can review Key Native if you want. You can access, it's free of charge. And now what I'm going to do is just carry out a very small demonstration of Key Native so you can see how it is integrated into our strategy. So here is my cluster, what I showed you before. I'm going to change over to another one, to another namespace. And now I'm going to see if there's any service. Well, I can see that there is a service here that has been deployed. So I have a service of 42 hours ago, but in any case, I'm going to delete it to start all over again. Okay, so delete. And this is what helps us to integrate with Knative. And obviously, everything in Knative can be done with a line of commands. You can think about QM or QCanal, or you can think about Argo CB, and all of these projects of Kubernetes, all of them can be used from the terminal and obviously from Jamet. And I'm going to show you now this. Well, first of all, please allow me to show you something else. Let me show you what a YAML is in Knative. Well, this is a YAML, and it's very simple if we compare that with a deployment. And you can see that there is no deployment, there's no service, there's no pod, and I have no replica set either, and I don't define any egress or any routes. And all I do is define a service, and I say that I want to deploy this application in this container. And well, this is the process line, but I'm not defining anything more. And now I'm going to see if it works. Qubect apply basics and service, and now I deploy it. And the only thing I do is apply this YAML, and you'll see that what we get is a service list, and you will be able to see that there is a new service here that is already running. And I want you to see that we have this URL, which is public, that has been created, okay? And it's been created automatically because you must remember that what I said, that with serverless, we as users do not have to worry about anything because the app has already done a QCAP apply. In other words, it's found a node and it's deployed the application and the node that it thinks was the best, and it's deployed it there. And once it has been deployed there, it said, okay, what do I have to create? Well, what I have to do is create a deployment. I have to create a Kubernetes service. Well, here you are. You can see that I get deployments, and you can see that we have a deployment that is called Greeter 00001 deployment. And with Qubit, one get a replica set. So you get a replica set, and well, here where you get service, and you can see that we have several service, but we have a greeter service. So everything is created automatically. Although what happens if I were to modify something here? Well, for instance, get pods, and you can see that there is a pod that is about to disappear. It's on the verge of disappearing. Why? Because I've deployed a service and I didn't send it any request. And as I didn't send a request, the process was at 0. And this always happens. This problem always arises, and it always takes a very long time. It takes a long time to finish the process. It's something that I've never understood, but it takes very little to create them. But in any case, this has finished, and you can see that there's nothing deployed here. Why? Well, because if there are no requests, this means that it's not necessary to have the pod connected. But what about this if I copy this URL and I do a curl here in this URL? So I've done the curl, and it gives back a message, and you can see what it says here. And you can see that there is a pod. Why? Well, because you can scale from 0 to 1 or to n. The more requests you receive, you'd scale further and further. You'd get more and more pods. So Knative is a very powerful serverless solution for Kubernetes that allows us to adapt to our workload. And now you'll probably say, okay, well, how is this associated with this system, with the hybrid cloud? We've spoken about cost, and we've said what happens when I have an hybrid cloud structure, and perhaps as a cloud backup, but I need to have the services in operation there. But these are services that are working. When they're not being used, my provider is charging me for them, my cloud provider. So what I could do is that all of these services be key native services. In other words, that they be scaled to 0. And whilst I'm using the Google Cloud, for instance, these services would always be working. But if there's a problem, nCloud automatically moves me to Amazon. And in this case, it would have its services disconnected, so they wouldn't be able to charge us. But as these are generic services, they would automatically scale towards 1, or their key native services. And I'm talking here about what happens if they fail, but it could also be a completely different problem. What happens if I'm receiving many communications in the cloud? Let's just assume that I have a GCP, okay, where I have a region in Frankfurt and I have another region, I don't know, in Singapore, for instance. And it so happens that my cloud, my Google Cloud in Frankfurt is receiving many, many, many requests. And I'm starting to saturate my cloud. So what we can do with Scupper is start to send requests to other clouds in another region. So, but it's much better to have and more extensive possibilities and than to not be able to manage the request, and then Scupper would be able to send responses to cloud, to the region of Singapore. Anything that works with cloud also works with Scupper. So let's see the demo again. It's an interactive demo, and here you have the links if you want to access, and here is the code so that you can reproduce the demo, so that you can play it back. Okay, so I'm going to move into a different space.
Tendré que logarme quizá. Qué raro, porque me he logado justo hace un momento.
Well, wait a minute, I have to relocate because I did that just a few minutes ago. Well, here we are. And this is what I want you to see. Well, the first thing I want you to see is that I have my backend that has been scaled to 0. This is Google. And then I have this backend, and I'm going to change again to the hybrid cloud. And this is the same demo. We can see it in Amazon. And you can see that both of them are scaled to 0. And here I have the app. The app, well, it's somewhat different if you want. But it's just a little bit different, but it's basically the same thing. And there are no messages. And I'm going to write Álex and send a request. But let's see if I am able, let's see if I can show both things at the same time. I'm not sure if I'll be able to do that, but wait a minute, I'll give it a go, even so. No, not yet. Hold on. And what I'm going to do is send a request, and you'll see how, in the case of Google, how this is scaled automatically. So it hasn't been possible right just now, but in any case, you can see it now. You can see how the system is automatically scaling. It was scaled to 0, but now it scales to 1, and finally it sends back the answer. So if I were to write, for instance, Soto, it would also work too. Right, so I've just written Soto, and it scales up, and now you can see that I have configured this cloud to be rapidly descaled. And I think that it was 15 seconds, and the cloud automatically is going to descale if no requests are received. And you can see that I have my cloud here, my Google Cloud, and the Amazon Cloud is still scaled to 0 because I'm not doing anything there. If nobody sends me anything, I don't do anything either. And this is scaled to 0, and the Amazon Cloud is at 0, the Google Cloud 0, and they're not charging me anything. So then you'll think, so how can we test and make sure that this goes to both clouds? Well, I'm going to show you this in the following manner. I've configured these clouds so that when more than 15 answers are received in parallel in the Google Cloud, Scupper starts to will send out requests to the Amazon Cloud. Okay, so So 15 requests in parallel sent to the cloud, and then automatically the next requests are sent to another cloud. Anyway, let me do a hey. I'm not sure if you know what that is. It's an app. It's an app that allows us to simulate concurrent customers. And here what I'm doing is simulating 20 concurrent customers. And let's just write Santander. And this is the text that I'm going to send. And what I want to do is 20 concurrent customers. And now what I want you to see, and I want you to see that it's perfectly well explained, is like the GCP cloud. It's up and running. And the Amazon cloud, well, both of them, Scupper has automatically redirected traffic towards this other cloud. So I could not make this change, but what I could do is scale to 0. So the cloud would stop and then would automatically start again. So it's exactly the same thing. The only thing I've done is change the conditions of when I have to perform the switch. And you can see that after 15 seconds in the Amazon cloud, well, they start to stop charging me. And in the Amazon cloud, no, sorry, in the Google cloud, as there's no request, no charges apply either. And well, this is, well, you have everything on the demos. And well, as a summary, because I've only got 2 minutes left, and the first thing is that Kubernetes is your platform for Apple Cloud. And I think that you're going to have a very consistent experience. Scupper is going to help you to be able to interconnect all of the clouds. And Knative is going to reduce costs. And finally, well, here you have all of these references. Well, these are the 2 demos that I've just shown you that are here. And I'm afraid that I've run out of time. But here there is an app that is called Hybridize app. But in any case, there is a database there. In other words, many of you are possibly wondering, okay, this is very good because it works. But what about when I have a database involved, when I have data distributed in multiple locations? How can I do this kind of program? What happens if part of my database falls into a cloud? Can it carry on working with my app? Well, this is the example where you can see things. And well, that's all. And as I pointed out before, this is my tweet, and this is my email address. And thank you very much. Well, congratulations, and thank you very much for sharing your experience and for sharing your knowledge too. Without a doubt, it has been extremely important. I've enjoyed it a lot, and I enjoyed your vision of Kubernetes and OpenShift as a layer of abstraction that allows us to have a homogeneous experience in several clouds, or how sometimes we can use that hybrid cloud model as a support to meet the regulations and to meet data protection requirements. And I also like Knative too, as a layer of additional abstraction on serverless. I think that both serverless as well as Kubernetes, I think that these are elements that over the years we have become more and more mature, and it's interesting to create additional layers over and above a high level of abstraction. But in any case, well, we have a couple of questions here, if you want. And there is a question, well, let's see, there is a question on whether we can establish affinity rules. So, well, for certain pods to be placed in certain clouds and so on and so forth. And so what do you think? What do you think about this? I'm not sure if well, do you think that this kind of affinity can be established? Well, you can create affinities between clouds, but not in terms of the pods that are going to be deployed. I'm talking about Scupper, although there's a cluster management product from OpenShift, I think you said, that allows you to establish this kind of affinity. But what I've showed you here is for Kubernetes. Well, you can deploy these demos in a functional manner. And well, this is something that has to do with OpenShift. Okay, good. Well, we have another question here that has to do with how do serverless and key native, how compatible are they with Scupper? Well, yeah, well, that's the demo that I showed you has to do with Scupper, with key native. And well, what you have is a small proxy, is a Scupper proxy that is in operation. And when the request is received, it is made transparent to the key native service. And here, this is where the key native logic enters into the picture and starts the system up. But what I have to say that in the case of Scupper, let's say that there have been fluctuations. And the example that I showed you is that there's a proxy per each service. But also in the last versions of Scupper, you can have only one controller for all the apps. In other words, one proxy for all. And this reduces costs even further. So you always have two clouds, and you're going to have well, a little bit of cost from the other cloud. If you use it as a backup, there's going to be a little bit of cost, but it's going to be minimal in comparison to or compared to having all the app deployed. That is if you have a backup cloud. But if you have it divided by a regional format, well, that will depend on each region, of course, and the capabilities of each region. Okay, well, we have another question for you, but I think that it's the same as the first question that has to do with the affinity of, well, between one cloud or another. Well, yes, this is something that can be configured in Scupper. What you can't configure is which pod goes in which cloud. So you can, well, you can have an affinity in terms of requests. So I want to send a request to the nearest cloud, or depending on the workload or according to the workload. And that is something you can do. All right, okay. Well, wonderful. And if you think, what we can do is stop here, Álex. Thank you very much for your contribution. And today we have discovered two open source projects, Scupper and Hey. I knew nothing about them until today. And well, thank you very much indeed. Thank you very much for your time with us. And well, as I said before, congratulations on your lecture. And well, thank you for inviting me.